lecture we want to look at a proof using bijection of a very well-known identity among binomial coefficients. For n greater than or equal to 1, we have nck equal to nc n minus k. So this number is n choose k. That means it's a number of ways to select a k element subset from an n element set, or simply if you say the number of ways to select a k objects from n objects. For example, let's look at what is this one for C2. So for C2 is nothing but the number of ways to choose 2 elements from 4 element set, right? Now how do you calculate it? So before you calculate, let us just list those possibilities. Suppose you have a 4 element set of x, y, z, w, all of them are distinct. Then these are the possibilities: x, y, x, z, x, w, y, z, y, w, z, w. So actually you got 6. Now we have a formula which goes like this. For C2 means you have to multiply it backwards by 2 times 4 times 3, then you start from 1 and multiply forward 2 times, so divided by 1 times 2. That means you get 6, the actual value. Now how do you calculate using this 3C2? You go backward by 2 times, so 3 times 2 and forward 1 times 2, which is 3. So now let us look at whether the theorem is true or not. So for the theorem tells you that 4C3 is equal to 4 minus 3, that is 4C1. Let us calculate both. So 4C3 means you go backward in the numerator 3 times and go forward by 3 times, so you get 4. So 4C3 is 4, and 4C1 is 4 because there are only 4 ways to select one element from a 4 element set, right? So now so let's look at if A and B are finite sets, then cardinality of A equal to cardinality of B. We can prove this if we can establish a bijection from suppose bijection phi from A to B, such that so if it is possible, we can say that they have the same cardinality, right? Bijection means 1, 1 and 1, 2, right? So let's first construct so let A be an element subset, and we denote AK by the k element subsets of A, right? All k element subsets of A. And n minus k is nothing but all n minus k element subsets of A, right? So in this case we can see k is running from 1 up to n, because these are the possibilities for subsets, right? Definitely k equal to 0 will work. That is nothing but the empty set. Anyway, so what I want to tell you, right? So why do I choose this? Because AK, what is the cardinality of AK? So cardinality of AK is nothing but n choose k. Similarly, cardinality of n minus k is n choose n minus k, right? Now, so let's look at some, so how do I construct this function from ak to an minus k? How do you construct a bijection? My simple idea is if B is one of the fellow from A, then suppose it contains k elements, then what about the complement with respect to the set A? Because it contains n minus k elements, because the union has to be the whole set A, right? So using this, I construct a function phi which is from ak to an minus k in this fashion. a set from AK and an AK element set K, B goes to B complement, right? So definitely B complement belongs to A n minus K because it contains n minus K elements. So we'll check whether it's an injection, right? That means whether it's 1 1 or not 2. So in order to prove that, we take phi of B1 is equal to phi of B2, which is B1 complement equal to B2 complement, right? Now we have to prove B1 equal to B2. So in order to initiate the first step, we have to show B1 subset of B2. So that means we take an element Y from B1. That means Y is not in the complement of B1. That's very easy, right? Because B1 complement and B1 is non-empty. So Y cannot be in both B and B complement. So Y cannot be in B1 complement. That means you can replace this by B2 complement from here. That means Y does not belongs to B2 complement also. But that means Y belongs to B2. Right? Yeah. So the assumption is very clear that Y is an element of A, right? That's very important. So we take an element, Y is an element of A. Because if I say Y is not belongs to B2 complement, then how do you ensure that Y is in B2? Because Y is in A, right? That's an important thing. Now, so you have to assume in the first case that Y is an element in A. Then we are talking about the subsets, right? Yeah. We are not talking about anything outside. So now, in similar way, you can prove B2 subset of B1. That means B1 is equal to B2, right? So, yeah. Then, so how do you get Y belongs to A? Because we have already Y belongs to B1. That proves Y is in A. So no worries. Right. Now, so we prove B1 equal to B2. That means f of x equal to f of y implies x equal to y. That definitely tells you that f is a injective function. So that is an injective function. Phi is injective. Now we have to prove the ontoness. For that, I take one element B from A n minus K, and I claim that B complement will work. What do you mean by that? If B contains n minus K elements, definitely B complement contains K elements. So it is a member of AK. Now let's plug B complement in phi. Then phi of B complement is equal to B complement whole complement. So that is B. As it's a basic set theory, you can prove that easily. That means B complement goes to B. That means for any B in the target or in the codomain, you have a set in AK. That means it is onto. That means they have same cardinality, AK and n minus K. That actually implies NCK equal to NCn minus K. So this is one proof using bijection. Thank you.